way in which the logic and longevity be optimized for
Not today.
Hello and welcome to another episode on Hydrogen Energy News interview series. Today, I'm excited to talk with Alberto Vitale Brovarone, the professor from the University of Bologna, who's turned hunting for hydrogen into an adventurous quest. As the lead on the IRC Deep Sea project, his recent Greenland expedition was more than just dodging icebergs and wild animals. It's about uncovering the secrets of geological hydrogen. Think of him as a modern day treasure hunter, but instead of gold, he's after hydrogen that could revolutionize our energy future. Get ready to dive into the world of hidden energy sources, unexpected fieldwork antics, and why geological hydrogen might be the coolest thing since sliced bread. Alberto, welcome.
Hi, thank you. Thank you so much.
For the beginning, tell me, who is Alberto Vitale?
Who am I? I'm a curious person. I think that's my major strength. And I ended up to be a geoscientist. So that is my passion, what consumes something like 25 hours a day. I work in the geosciences. I dream about geosciences. It's really my passion.
That's probably the best answer I've got so far. Tell me a little bit about the project and about the background of your Greenland expedition.
So the project Deep Sea focuses on, let's say, hidden energy sources. The scientific discussion on deep energy started many years ago, decades ago, and it's very controversial. I will not focus on that because it's a very long and an interesting topic. But as a geoscientist, and more specifically as a petrologist and geochemist, I can clearly identify that there is a missing part of the story. Because in petrology or geochemistry, it's not a big problem to talk about molecules like molecular hydrogen or methane or others. But especially for the deep Earth, the fact that these molecules can act as energy sources is not really taken into account. Specialists, of course, know that. But in the way we approach our fieldwork, our conventional work on the microscope or doing modeling or whatever, or even teaching about these rocks and these molecules, we do not take into account their energy potential. And now this is just crossing a completely new discipline that is unconventional energy, unconventional hydrocarbons, unconventional or geologic hydrogen. And this is new, this is fresh, and this is the perfect moment to invest time and money. I was lucky enough to get this large grant from the European Commission. It's the perfect moment to spend time looking at where these hidden energy sources can be formed, how they form, how they move through the crust and through the mantle, how they interact with the surrounding rocks, and if they can maybe even locally reach the surface or reach the biosphere. And this very last part is central in my project. I would really like to understand if, at least in one place that is still preserved on Earth, we can put our finger on a small portion of the ancient crust where these deep energy sources could feed life forms, especially microbial forms of life that populated the subsurface of the Earth. So this is really the long-term objective of the project and what we want to do.
What key lessons did you learn from the expedition that you will apply in your future research?
The key lesson is, and the lesson that was quite rewarding because I really hoped to get there, is that hydrogen, molecular hydrogen, of course, is everywhere. Maybe not necessarily everywhere on Earth, but everywhere in those places where we may expect hydrogen to be present. In the case of Greenland, we are talking about old continental crust, what we generally refer to as Precambrian continental crust. So older than roughly 500 million years. And our expedition had a few issues, and we had to change our plans multiple times. So in the beginning, we knew that hydrogen is actually present in one area of Greenland, and we wanted to go there, but we had to change our plans, explore a new area with no initial clues on the presence of hydrogen. But finally, we found hydrogen everywhere. And please do not misunderstand what I'm saying. I'm not talking about diffuse hydrogen emissions or anything like that. I'm talking about what crustal rocks tell us about the past presence of hydrogen inside the porosity of the rock, inside fluids percolating the crust at multiple stages in multiple rock times and at multiple times during the Earth history. So that's the lesson. Hydrogen is everywhere when and where you look for it.
What specific rock types did you encounter in the different areas you explored?
A large variety of rocks, from sedimentary to igneous, from felsic to mafic in composition, even ultramafic, rocks forming these Precambrian basements can be very diverse and complexly mixed together. So it's hard to talk about one single type, but it was like first year petrography course, just meeting nearly all rock types together in a small area.
You mentioned rocks ranging from 3 billion to 1.2 billion years old. How did the geological formations differ across these vast timescales?
They differ a lot, including their potential to produce hydrogen during either their formation or their spontaneous aging over geological time. Some of them represent a very important stage of the evolution of the Earth, and especially the creation of large continental crust, which is important to us because we need to live and to build our houses on exposed lands. So it was also quite emotional to spend time and to walk on those pieces of very ancient continents. And some of them were, really a vast range of transformations of that very same ancient continental crust during multiple events of mountain building. So when continents collide and mountain belts form, then some of the formations we worked on formed as or through the erosion of these mountain belts and sedimentation in sedimentary basins, and then the metamorphic transformations of these sedimentary rocks to meta-sedimentary rocks, and then multiple stages of magmatic activity at multiple times. So really a vast range of events and rock types all together packed in a very narrow area.
What specific metamorphic minerals did you identify, and how do they relate to potential hydrogen generation?
Um, that would be a long list. So what we are trying to develop in our group is new knowledge about how to retrieve the presence of hydrogen in the past. You know that hydrogen is very volatile. Hydrogen likes to hide. So unless we can measure and have hydrogen at the surface or in deep accumulations, what we still miss is how to understand that hydrogen was present in the past. And speaking of geologic fluids, that is something that is already somehow developed in the scientific community. For example, we can easily understand if water was present in the past history of a rock sample. We can look at metamorphic reactions or alteration reactions, and we can say, oh, yes, there was water moving around here. But for hydrogen, it's different because that culture, that knowledge is not available yet. So we are not really focusing on specific minerals. Yes, of course, we have a short list of key minerals, but we are just testing them. So we are not even sure they are the best targets. We try to test hypotheses. That is probably the best answer. We find a rock type. We know that hydrogen can be present there or may be present there. And we based our sampling strategy uh, according to the most obvious tests. For example, we know that this rock is made of quartz, feldspar, and this and that, or carbonate, or the most common crustal minerals. What if hydrogen was there? What type of reactions should we expect? What kind of traces? And there's no answer to that. So for now, we're just taking samples um, and way to answer these field-based and or very intuitive questions.
What would be your prediction? Where are we now in terms of finding, actually getting this hydrogen uh, at this point in time? Like, we are still researching. Can we expect a real project in a year or two,
You
like
mean a
drilling
project
for
to
hydrogen?
you mean to extract hydrogen
Yeah,
in Greenland?
in general, and
Okay.
in Greenland.
So extraction is something, and of course, extraction is benefiting from uh, a very vast knowledge coming from the oil and gas industry. And I'm not really an expert of that part. And honestly, I try to stay a little bit away from that type of research. Not because that research is not important or timely, it is, and I really believe so. But because a very long list of questions about natural hydrogen, um, open questions, need free research activities. I mean, research activities that do not have any bias coming from industry or economy based strategies. And the fact that we decided to study hydrogen in Greenland is a demonstration of this approach. Greenland is a special country. The population is very small, and I think up to 60% of their energy sources are from renewable sources. So they don't really need hydrogen. And right now, moving hydrogen from Greenland to elsewhere is not possible. That is still a major challenge. So we are probably the first ones exploring hydrogen in Greenland, but there is an obvious reason why, because that's not the best place to extract hydrogen, but that's the best place for us to develop our fundamental research activities free of any potential bias.
You mentioned a makeshift device for preliminary analysis. What parameters were you measuring and what initial results did you obtain?
That is a funny story. So I mentioned that our plans had to change at the very last minute. And if we already knew that hydrogen was present in the initial area, we didn't know anything about hydrogen in the new area. And that changed a lot our strategies and our way of conducting fieldwork and sampling every day. So very soon during our fieldwork, we started to really need or desire this type of information. Is hydrogen present? So we decided to build a very small device. We took a few pieces of steel we collected on the ground, a plastic glove. We had a portable gas analyzer with us. And we decided to try crushing rocks or small pieces of rocks inside this device and see if hydrogen was present inside. But finally, it was a disaster, and mm, it didn't work. It was too, let's say, handmade to work. But we had a lot of fun, and that also motivated us to change a little bit our sampling strategy, our ideas. So no results in the field, but a very positive experience.
We'll definitely come back to the strategy changes, but what specific laboratory techniques will you use to confirm the presence and quantify the amount of hydrogen in these samples?
The easiest one is Raman spectroscopy. So basically, we cut thin sections of rocks, um, which is very conventional, and then we look for fluid inclusions. Um, then we can just spot these fluid inclusions with a micro Raman spectrometer and check for the presence of hydrogen. So if the thin section is already there, it takes like 10 minutes, 15 minutes to have an answer. And this is what we did. We carried some samples with us. Most of the samples are still there. We are waiting for them to be shipped. And we cut thin sections very quickly, and we did some Raman analysis, and the answer was quite positive, even though we analyzed just a few samples. Hydrogen was there, so we were quite excited. And besides Raman spectroscopy, there is a long series of techniques. It really depends on the type of information you want to get. We are still in the stage where we want to um, target as many types of information as possible. And this is because it is too early to be more specific. Of course, we could just target isotopes or concentrations, but that's not enough to understand how these deep systems work, especially how hydrogen is produced, reacts, migrates inside these systems. We need to go from microstructures to chemical analysis to modeling, basically everything.
What are the possible origins of the hydrogen you're investigating?
That is a very good question, and have no answers right now. Of course, if you ask the possible sources or processes, I already have a few ideas, and those are the most intuitive ones. Uh, Trying to be specific on the area we explored, we range from magmatic or late magmatic processes, especially for the youngest rocks in the area, those dating back to 1.2 billion years. Some of those igneous systems may be associated with hydrogen formation, especially during the latest stages of the magmatic activity. Then aqueous alteration of many rock types containing iron or other redox sensitive elements. Then radiolysis. Radiolysis is the most obvious one in Greenland. But I don't think that is the only one in the area. And then for some formations in the area, we can also think about thermogenic maturation of organic matter. Of course, we still need to test all these hypotheses, but those are, it's funny because they are the most plausible one based on the local geology, but they are basically covering the whole range of hydrogen forming processes we know. So it's going to be quite challenging to disentangle uh, the rock record and to identify individual types of hydrogen or potentially they're mixing in each sample.
You mentioned expedition faced last minute changes due to icy conditions. How did you adapt your research plan to and the logistics?
Those were very stressful days because basically we knew about uh, this drift ice situation the day before. So field trip in Greenland is very expensive and everything must be prepared in advance. And everything was ready in advance. But then the day before the departure, we had to decide whether to cancel the trip or to go and maybe wait a couple of days to see if the drift ice situation uh, get better. So we decided to go there, but finally the situation was getting worse and worse every day, and that was really stressful. So we took every spare minute on the plane during the stops, um, late in the night, to find a plan B and maybe a plan C. We downloaded tens of articles. We downloaded geological maps from multiple areas, and we finally made our new plan. We basically found some kind of equivalent of the previous area, but with major unknowns and a much larger diversity of rocks. So we tried. We don't have an answer. I cannot say if the final outcome is positive or negative. For now, it seems to be quite positive. So let's hope for that. But we still have major uncertainties.
When you encountered discrepancies between the geological map and the field observations, how did you reconcile these differences?
So we had a few examples of that. It's funny because one may think that because Greenland is such a remote area, the mm, geological information we have on those areas is limited. But for the geological maps, we had 4 or even 5 versions of the local geological maps. Some of them are the official ones, some of them date back to the 60s or 70s and were compiled by very young master students from many different countries in Europe. So with very different cultures and ideas. And they were all similar, but you know that the devil is in the details. So in a few cases, we got lost. We based our strategy based on one map. Then we went there and we discovered that the rocks were quite different from what was reported on the map. Then we discovered that another map was actually showing the right names, or at least the right interpretations. And we tried to reconstruct the evolution of ideas from one map to the other. Um, that was a very nice experience, to be honest. Of course, when you are in the field and you get lost, is not funny. But finally, we learned a lot from this very long database of maps and ideas.
How this limited time frame of your expedition influenced your research priorities and sampling strategy?
Um, yes, as I said, fieldwork in Greenland is expensive, so we had to restrict the number of days as much as possible, and to make sure that during those days everything, and especially the sampling objectives were achieved. It's funny. I come from the Alpine realm, so I know how to mm, deal with one day in the field or 1 week in the field. In Greenland, it is different because Greenland is gigantic, and the most frustrating part for someone coming from the Alpine realm is that there is no tree, there is no forest, and it's basically one gigantic outcrop. You don't know what to start with. You don't have just one single outcrop because the rest is vegetated, and you can spend hours on that outcrop. It's very hard to make plans and respect those plans. For example, every day we made our plans in the morning or the day after, and I remember one specific area along the coast of an island, and the plan was to walk for at least 3 or 4 kilometers, which is nothing in the Alps, really nothing. But finally, after 8 or even 10 hours, we were still working in the first kilometer because there is so much rock and so much information that deciding where to stop or what to skip is very hard. And also what to take, what to collect, which is the best sample, because they all look the best sample. So I hope or I think we did our best, and we will see. We will see. But Greenland requires some experience.
Based on your initial observation, what is the potential for natural hydrogen as a energy source in Greenland? Although you said they don't need it, but what's its potential?
They don't need it right now, but I know they are exploring multiple types of alternative energy. As I said, Greenland is a special place. There are very remote areas, remote villages, and energy supply is not necessarily easy. So I know they are exploring. So not today, but maybe soon, hydrogen may become a very important resource. But not for other countries, at least right now, because moving hydrogen from one place to another is not easy.
How would exploration and potentially extraction of natural hydrogen impact the fragile Arctic environment?
That is a major issue, of course. I know that the self-government of Greenland is very cautious with that. We cannot imagine how fragile the environment is unless we read, we study about it. Um, so I fully understand their strategies with mining, with exploration. And for hydrogen, that would be the same. Again, I'm not an expert in this field, but I'm really glad uh, uh, local authorities are uh, very uh, cautious with that. That is the real issue at stake. So it's hard to tell, of course,
Yeah.
if hydrogen extraction is feasible, easy, safe.
Hmm.
I don't know, maybe, but probably not for now.
Did you encounter any unexpected geological features or phenomena during this expedition?
Yes, many. I remember one that was the very first day, or even the first outcrop. Uh, or even the first rock that I hammered. So there was this rock. I cut it into uh, multiple pieces. I took the first one, and looking inside the rock on the fresh cut, I could see very clearly very uncommon structures or features, but very similar to a series of rock types that we have found in multiple places, from the United States to Mongolia, the Alps in Italy, and that are systematically associated with hydrogen. So that was a big surprise. And I was even more than surprised because that was the first rock. And the potential link to hydrogen was so strong that it was somehow suspicious. Finally, we already analyzed one of those samples, and that specific structure is not related to hydrogen, but to other processes. But hydrogen is also present in that rock, and we still don't know why. But that's, of course, very exciting.
What were the most exciting and rewarding moments of the field work?
Many. Uh, that probably was the most beautiful and exciting experience of my professional career. It's a very special place. One moment that I remember very well, one of the last working days, we prepared our campsites, a subgroup, uh, went fishing because we didn't have enough food for dinner, and finally, after dinner, we were exhausted. But you know, in those regions, in this period of the year, there's still quite a lot of light, even late in the night. So with one PhD student and another colleague, we decided to do some extra field work, midnight field work, which is something you cannot do every day, of course. And it was so relaxing because we were exhausted. We didn't expect anything from the field or even from us. So we took it very easy. And we also took a midnight picture of that very special moment. So that's probably my best memory of the trip.
What are the next steps in your research on natural hydrogen?
That's a good question. And I don't have a specific answer. Um, as I said, I'm not interested in finding hydrogen accumulation. So that's not my objective. My my feeling about geologic hydrogen is is that we don't know anything about it. Of course, there are papers and there is a growing number of colleagues working on it. So we know something about it, but that's just the tip of the iceberg. And when I think about my previous work and the work of a very long list of colleagues working on crustal and mantle rocks, I realized that no one on average is taking into account what we already know, the little we know about hydrogen. So this is a revolution. So I don't know where my research is going to go besides the next month, but I have a very justified feeling about what natural hydrogen is right now for the scientific community.
And what it is?
Hydrogen is the 12th player. We have reconstructed the Earth history. We could explain almost everything on Earth just relying on 11 players, like in football. And we know the roles of each player, right? There's the goalkeeper, there's this, there's that. We can find one there, another there. But then we discover that there is the 12th player. And this player is transparent, is invisible, like hydrogen is. But we realize day by day that the final outcome of the match strongly depends on this invisible player. So everything else becomes foggy because our rules, our explanations of natural phenomena, or our interpretations of chemical analysis of minerals, of fluids, were necessarily not correct, maybe just slightly wrong, or maybe in some cases completely wrong. So my research in the future, trying to deal with the 12th player, the invisible one.
In that context, can natural hydrogen be the future energy source we did not expect?
I hope so. I don't have an answer. And I think that to answer that question, one needs some basics in the business component of this topic. So it's very hard to predict. And of course, we may discover that a lot of hydrogen is there, or even everywhere. You just need to dig a hole and you find hydrogen. But we are talking about business, and there are multiple interests around, so it's very hard for me to tell. But what I can say as a geologist working on the fundamental component of geologic hydrogen science is that hydrogen is everywhere. There is nothing else I can say. Over the past years, we have been conducting field and research in very diverse area of the Earth, very different ages. Some were obvious for hydrogen research, some were absolutely not. And we found hydrogen everywhere. So there is something big we still need to discover. So I'm very positive.
How do you plan to share your findings and raise awareness about the potential of natural hydrogen?
Slowly, little by little. on one hand, I know that the community needs as much information as possible. That's the perfect moment to share. And this is what we are doing through these interviews, through presentations at conferences, and so on and so forth. On the other side, it is very easy to be wrong in this specific moment of the hydrogen revolution. And to be very honest with you, it's also the easiest moment to publish about hydrogen, because it's hard to contradict what people is saying about hydrogen. We need
Yeah.
very little evidence about hydrogen to publish a story. But it's also easy to be wrong. And I really think because of the potential impact that geologic hydrogen has on the community and on the energy transition, is that we must be very careful with those mistakes.
Definitely agree on that one. And I'm expecting this presentation. Alberto, thank you for being my guest today. It's very
Thank you so much
insightful,
for
very interesting. First time that we actually have the field results explained, because we still don't have very firm knowledge and facts. Alberto, thanks again and hope to talk to you again.
Thank you so much for this very nice interview and for your very precious contribution to the community.